In this video, I'm going to talk about when the sampling distribution for a sample mean is considered normal. In the last example with the fishing pond, we were told that the population was normally distributed. This guarantees that your x-bar distribution will be normally distributed as well. However, what if you don't know the distribution of your population, right? And typically you don't. This is where the central limit theorem can come in handy, because it says that as your sample size increases, the sampling distribution for x bar will become more normal. And so what this essentially means is that as long as you have a large enough sample size, your x bar distribution is going to be normal. In an intro stats class, it's pretty much been agreed upon that a sample size of 30 is large enough. However, in the real world, you should be very skeptical when you see a sample size of 30. It does depend on what the article or whatever is talking about. But if you see a sample of size 32 and they're trying to generalize the results to the entirety of, let's say, America, that's not a good sample size. And so realistically, 30 is not large enough. However, for the purposes of class, it is. And so let's continue and look at these examples. In the first one, or for all of them, we're going to figure out if the x-bar distribution is normal, and we're told a bunch of stuff about it. If it is normal, then we're going to find the mean and the standard error. In the first one, we know that x has a normal distribution with mean mu equal to 18 and standard deviation sigma equal to 13. And we're going to draw samples of size 5 from the data set. The first thing we do is we determine if the sampling distribution for x bar is normal. And there are two things that we can use to determine this, one of two things. Either we're told that x has a normal distribution, or our sample size is greater than 30. Our sample size is not greater than 30, it's 5. And so we need to rely on x being normal, and we have that x has a normal distribution. And so here, we can say that the x-bar distribution is normal. So now that we know that the x-bar distribution is normal, we can find the mean and the standard error. And so the mean, mu sub x-bar, remember that's just the population mean. So here this is going to be 18. And then the standard error, sigma sub x-bar, that's going to equal the given standard deviation divided by the square root of your sample size. So here you're going to have 13 divided by the square root of 5, which gives you 5.8138. Now let's move on to part B. Part B says, suppose you know that the x distribution has mean 75 and standard deviation equal to 12, but we don't know whether the x distribution is normal or not. And we're going to draw samples of size 30 from the data set. So here, we do not know if the x distribution is normal, so hopefully our sample size is at least 30, and it is. So here, the first one, the x-bar distribution is normal since n is greater than or equal to 30. And so I guess up here I should add since x is normal. Normally distributed. Okay, so again, for part B, now that we know it's normally distributed, we can find the mean and the standard error of the x-bar distribution. Again, the mean is equal to the given mu, which in this case is 75. The standard error, sigma sub x-bar, is equal to sigma divided by the square root of n. And here you're going to get 12 divided by the square root of 30. And this is 2.191. And that's again rounded. So now let's look at this last one, part C. Suppose the x distribution is skewed right, so the x distribution is not normal. It has mean 15 and sigma equal to 1.8. Suppose we draw samples of size 10 from the data set. Well, the first thing we need to look for is whether or not the x-bar distribution is normal. And if we look at the given information, we can't say that it is, right? So here, the x distribution is not normal, and n is less than 30, so we can't say anything about the x-bar distribution.